So what I'm doing for the audience right now is I have started the live stream, but it takes like 15 seconds to go through. So I'm doing the audio test so that you all don't scream at me after that. I promise the amazing panelists backstage, you'll just see them in a second. Awesome. I can hear myself. There's an echo, which means I need to close that tab. And now I'll start by introducing the panel. Hey, everyone. Thanks for joining the Responsible AI panel. We'll be learning from some absolute leaders of the field, and we'll be learning how to interpret models, how to use explainability in AI, how should you use these models when you're deploying them into production, how can you catch things, even mishappenings before they might happen. And this is a live panel, so you're welcome to ask the questions. With that, I'll start by introducing everyone on the panel, and I'll go in the alphabetical order. First, we have Dr. Erin LeDell. She's the leader of H2 AutoML. She's been leading that effort and also the chief ML scientist at H2 AI. She's been with the company for 8 years, and this is the second time I'm interviewing her. So thanks for joining, Erin.
Thanks.
I forgot a fact I had written down, but you've been involved in diversity for a long time. You've been the leader of women in machine learning and data science community as well. So wanted to share that fact as well. Next, we have Dr. Kim Montgomery. She's a competitions grandmaster and a principal data scientist at H2O AI. Internally, we have a lot of reading groups, as you might expect. Kim is quite passionate about this field generally, and she's also been leading the internal efforts for paper reading groups in this domain. So I managed to convince her to join the panel as well. Thanks for joining, Kim.
Thanks.
And finally, we have Parul Pandey, who's many things. So I'll keep it short. She's a Kaggle Grandmaster in the notebooks category. She's also one of the best authors I know in the field of machine learning. And she's also a top voice on LinkedIn for good reason. She has a very big community of 100,000. I think it's grown beyond that, people on LinkedIn, where she shares very high signal stuff in the field of explainable AI and machine learning broadly. Thanks for joining, Parul.
Thank you, Sanyam, for having me. I'm pretty excited to be on the panel.
So I'm excited to learn from you all because I do a lot of deep learning panels, but I'm a total noob in this field. So I'll start by asking this question: what's one example that you can think of that taught you where AI can negatively possibly impact millions of people at scale? Something that convinced you to start taking efforts in this domain. And maybe you can start with Erin. We can go in the alphabetical order.
Sure. Well, one thing that I can think of that like millions or maybe hundreds of millions of people touch every day is like a search engine. So if you, for example, had any kind of biases in your search results, that would immediately impact many people and also impact kind of like what they view about the world as well. So that type of thing would be really important to fix if problems were found.
Yeah, I would change all coffee results to chai if I can, if I had the power. Kim, I'll ask you the same question next.
Yeah, biases can show up in various models and affect people pretty broadly. For instance, if there's bias in a credit card model, it can affect who's getting approved for a loan. If you're using AI for medical tests, sometimes they work better for certain groups of people than others, and certainly that would affect who's getting correctly diagnosed.
Yeah, it's also an active discussion always because it's human versus AI, and sometimes it's human in the loop versus completely automated. So it's quite a challenging problem also, and like always an open discussion. Parul, same question for you.
Yeah. So there's this recent example that just comes to my mind also because one of our customers, CB, is in Australia. So it's about the robo debt scheme that happened in Australia, um, which was pretty recent actually. So it was implemented by the Australian government to actually automate the systems to identify and recover overpaid welfare money. So they wanted to see the welfare schemes that were there in place by the government. Was the money from there going to right people? And they automated it, and they just wanted to see if there are fraudulent claims. unfortunately, it didn't pan out the way they wanted. And a lot of innocent people were flagged as fraud, and they actually had to return the money, and it caused a lot of tension, and so much so that the scheme finally had to be scrapped out. So this is a very pretty recent example of when things were not implemented the way they should have been. And if you want to look at more such examples, there's actually a AI incident database now where you can go and see what are the, and you can also report incidents that you feel are where AI didn't work the way we wanted it to.
Thanks for sharing that. Again, for the audience, if you're watching a recap, I'll have these links in the show notes or the description of the video. So I'm also curious to learn from you all. People assume that interpretability is somewhat more enhanced with boosted trees. Can you speak about the state of interpretable models in the realm of deep learning?
Well, I don't know if it's necessarily the case that interpretability is significantly better for boosted trees. If I have a model with 3,000 decision trees, it's probably equally difficult to really understand what it's calculating compared to a deep learning model. So I think they're probably could equally be considered black boxes, and how you would deal with that depends on what kind of problem you're working on. There are standard methods that work for most models. You can still calculate Shapley values and try to understand which features are most important. You can do things like counterfactual analysis, look at what happens if you change different features and how much you'd have to change different features in order to get a different outcome. If you're working with tabular data, sometimes you can set up something like a restricted neural network where you're restricting how it's dealing with the features. There are neural networks that behave more like GAMs and try to calculate functions of different features. And you can use that to try to understand what functions the network's actually calculating. And of course, if you're looking at image data or NLP data, there are methods of looking at which words in a sentence a model's considering when it's making its decision, and which parts of an image the model's looking at. Yeah, and there's Hydrogen Torch, which does a great job of that.
Yeah, so I'm just sharing my screen to an experiment I ran for the audience. If you're new to Hydrogen Torch, this is an experiment I ran where you can see that you have the heat maps available in Insights, and it's also available for text models like Kinset. I was I wanted to create an argument that maybe deep learning models are harder to interpret, but sounds like it's equally challenging. If you could share your favorite open source package or papers on this topic, something that you read recently, or any packages that you really look up to for explainability.
I can start. So I'm more of an R person. I use a lot of Python as well, but I prefer R. So some of the packages that I like in R, there's one that's called IML, which has been around for a long time. It's one of the earlier packages for doing model interpretability. It's by Chris Molnar, who also has a wonderful book about machine learning interpretability that is free. And it just kind of goes through a lot of the different methods and kind of really, I don't know, it's just organized in a nice way. It has it covers a lot of the major explainability methods, and it's free, so I like that one a lot. There's another package called Daleks that is DALEX. That's also pretty good for interpretability. And so both of these packages work on a lot of different models. So there's a couple packages in R that kind of do a lot of different machine learning algorithms. H2O package is one of them. Tidy Models is another package. So These packages aim to kind of work on a lot of different model types, or rather than just one. So that's another thing I like about them. Also, the H2O package, I'll just mention that. We have our own interpretability suite or explainability suite in there, and you can. It's a little bit more limited in terms of general interpretability tools. We do have a couple different interpretability methods, but we have a pretty extensive functionality to explain all the black box models. So basically any of the models that we have in H2O, including AutoML, we have functionality to explain the sort of AutoML run itself, not just the single models, but in comparing all the different models together. So that's another one that I'll mention.
Thanks, Erin. And for the audience, if you're curious about the H2O resources, you can always head over to our websites or documentation. I just shared the link. Kim, Parul, anything you want to add?
Yeah. I just like to add before for the boosted trees that you said. So instead of sometimes going for a completely black box model, like we know, there are models like what Kim also mentioned about general additive models, GANs, and then we also have explainable boosting machines, EBMs, which are pretty good in the accuracy as compared to the counterparts, the black box counterparts, but the results are explainable. You can interpret them. So I would always suggest, if you're working on a high-risk application, I think it's better to work with them as if it's possible. And for deep learning, I think Erin mentioned a lot of libraries. I think that encompasses everything in tabular. I think and other than, of course, like the SHAP, Lime, and other similar packages that you have. Captive and PyTorch, if people use PyTorch, it's a suite of, it's a great sort of an ecosystem which has all the explainable post-hoc methods in it already. So if you look at deep learning, there are basically, I would say, broadly two categories of how you could explain. One is by perturbation, like you perturb the input and you see what is the result on the output. And the other is gradient based. So for perturbation, you have like things like occlusion. For gradient based, you have grad cans, input gradient, then layer-wise relevance, propagation, and so on and so forth. So all these are actually included in Captem. And it's very familiar to PyTorch. It's a part of PyTorch actually, so extension of it. And so you can easily use that for your deep learning systems. I use that a lot. Similarly for TensorFlow, also you have tools like What If and similar tools. Yeah, and again, so these are some of them which I can just remember at the moment.
That's quite a lot. Thanks, Parul. Kim, anything to add?
Yeah, pretty much what people have mentioned already. Also, the SHAP package is always good for analyzing which features are important in a model. As Parul mentioned, EBMs and other models similar to GAMs can be useful in interpreting what a model is actually calculating.
Thanks, Kim. So that's quite a lot of resources generally, and these help you understand your models. But many times we always read those headlines not to point any specific one out. You end up realizing after putting something out there that we didn't check for some bias that the system already has. So how do we account for this while we're still building such systems?
I guess I'll start. I mean, I think one way to check is to use some of these open source, well, not necessarily open source, but just using software. There's a number of different tools that allow you to kind of measure biases. So there's sort of a procedure. I mean, there's actually a lot of different ways to check if there's biases. There's a lot of different metrics in some of these packages. I think there's one package that's open source by IBM that has like 100 different fairness metrics. So it's almost like there's too many different ways to check, and there's not a single way that you're supposed to do this. So that's makes it a little bit harder because it's not a single path to follow. And each data set might have different things that you might want to look for depending on the use case of the data. I think, yeah, the Fairness 360. So, yeah, I mean, I think just trying to come up with something that makes sense. I think it's kind of hard to give a general answer to this question. I think it's really data set dependent, and that's kind of why maybe reading one of these books, open source books or something about, I mean, in this case, it's more towards algorithmic fairness and things like that versus like how to check if something, I don't know, is how to make interpretable models. But yeah, not a great answer, but just generally using the tooling that's out there. There's always new stuff being created in this space. So there's always new papers that are coming out that have different ways to check things. When we talk more specifically about H2O tools in the latter half of the stream, I'll maybe mention, go into a little bit more detail about some of the stuff that H2O offers.
Thanks, Erin. I tend to ask a lot of stupid questions that are vague, so still thanks for answering that question. Kim, Parul, do you have anything to add?
Yeah, I think it's just like, yeah, Kim, please go. Because I know Kim has done a lot of work in the biasing and debasing space.
Yeah, like Erin said, there isn't one standard method, and you can't really just calculate one thing and decide, okay, if I'm doing well in this one metric, then my model is going to be fair in all situations, because you tend to want to look at combinations of different metrics. Generally, people start at looking at things like how the accuracy varies for different groups, just as a starting point. So various accuracy metrics for classification. You might look at differences in log loss, or differences in log loss and differences in AUC and differences in accuracy between different groups. You also want to look at the differences in error. Frequently for a minority group, they're underrepresented in the data set, so you get larger errors. So people tend to compare how the errors vary for different groups, and that's at least a starting point in understanding fairness.
Thanks, Kim. Many times people just care about the deadline, and they care about getting the model to a certain accuracy. That's just me, but that's a powerful answer to always cross check.
Also, I think in addition to the technical approaches, I think we should also sort of look at it from a like socio-technical point of view, because if I'm working in a team and I'm creating an algorithm which is going to affect the minorities, and my team itself is not diverse enough, I mean, we are already biased, and we are not going to create something which is going to be targeted towards, for the betterment of everyone. So we also have to combine technical and socio-technical approaches together, and because there's no like one correct answer for this. And I think once we sort of see that there is bias in it, I mean, some of the ways in which we would want to then remediate it could be like, we either go and like pre-process the data itself, like rebalance it, weigh it, or maybe in processing, like tweaking the parameters of our model, or even at times probably post-processing the results. Like if we see directly, things are not what we want it to be, and it's affecting the minorities in a way we don't want it to be, we might go and want to like post-processing techniques also. So it's like an iterative thing. And like I just agree, there's no like just one correct answer for this.
Thanks, Parul. That allows me to like also stitch my next question into that. Can you all suggest any low-hanging fruits that are like very obvious and maybe like everyone should think of when building systems?
Yeah, I suppose first of all, just thinking about which groups are present in your data set and how they're affected differently. So yeah, as I had mentioned before, that you'd probably want to look at how the model's behaving differently for different groups and even different combinations of groups. It could be that even if things are pretty fair for a single group like racial and gender, if you look at combinations of groups, you can still find subgroups that are being negatively affected for the model. So I suppose just starting by thinking about how your model might negatively affect people and checking how it behaves differently for different groups.
One thing that I'll add to that is like maybe you would use something like adverse impact ratio or something like that. So there's just some really simple metrics that you can use to compare the error rates between the different groups.
Sorry, I was just looking that up. Could you please, for noobs like me, could you please explain what that calculates?
It just calculates like the ratio between the errors in the different groups. So let's say you know train a machine learning model and you score like let's say you have let's say two genders in the group. So let's say let's say two sexes in the group, male and female. You would just kind of compare like the error rate of the female versus the male, and then if they're beyond a certain there's different thresholds that you can use, but like if they kind of are beyond a certain threshold, you might consider that to be like an adverse impact. And yeah, so if they're close enough, that's good. If they're too far away, it's bad.
Got it. Thanks for clarifying. Parul, do you have anything to add?
Yeah, I think one of the easiest thing to do could be like random attacks. Like you could do chaos testing on your model, and you just randomly change the data set, and then see how does your model behave in such a setting. And second important thing, I think what companies can do is stress testing your models. So exposing it to data set like of extremes like recessions and pandemic, and then so that if in future it sort of sees such a type of data, it's able to not give weird results. And you could still simulate such environments, right? And other simple things would be distribution shifts, looking for data leakage, quality of data set actually to start with. Is some of the things which can easily be done and should be made part of the machine learning pipeline.
Thanks, Parul. So I also had some general questions like I've just covered, but the panel here has built many amazing products at H2O. They've led many of the efforts. So I'll probably also ask a few questions about things that they have built. So maybe I'll try a challenging question. What's your favorite tool in H2O's arsenal of all products that we've built?
Specifically for interpretability.
Sorry, yes.
Okay. So I like the interpretability interface that H2O has. It's very easy and it works like just off the shelf. And a lot of the things that we use, the method that we use for explaining models are already built into it. So you just run the function and you get all of them with very nice interface with explanations. And if anybody here has used the H2O open source, I'm talking about the H2O's open source one, which works very well with the ensemble and AutoML as well as single models. So if you have your H2O models, I would encourage you to use that. So that's, I like the open source one because it's open, but there is a similar one in the driverless AI also.
The driverless AI I was screen sharing too for the audience.
Yeah.
Maybe Erin? You muted.
Thanks. I was just going to share with you a link of the open source one because I was going to, because that's my favorite one. So Parul already talked about it a little bit, but basically, yeah, it just has a bunch of different methods it works on all the different models that we have in H2O3. And yeah, specifically, if you're using AutoML, you should check it out, because it's basically, one line of code to train an AutoML, object, and then you get a bunch of models, and then another line of code to explain everything. So we kind of have like an auto explainer. We have all the individual functions as well, like when you want to get a specific method, like Shapley values or something like that. But we have this explain function, which is just sort of an auto explainer, where it just generates a whole bunch of what we call explanations, and it's very visual as well. So I think I guess almost every explanation that we have is a visual explanation. They also sometimes have data associated with them, but yeah, if you like plots and graphs, you just run that one function and it gives you a whole notebook full of stuff.
Thanks, Erin. Kim, same question for you.
Yeah, I'm kind of known for doing feature engineering and trying to really find the right features when I'm doing Kaggle, especially. So I tend to go straight to the feature analysis for tabular data. I want to look at things like Shapley and see what features the model's using, and which might give me ideas as far as other features that I'd like to build, and or if it's using something that looks problematic, then if it's using features that are problematic, that could give you a hint that something's wrong with your model. And similarly, PDP plots, just looking at how the output of the model changes as a feature changes, is frequently useful, as far as understanding how the model is using different features. There's a counterfactual app that I'm working on right now that can be useful just in understanding how you might change a specific instance of your model in order to get a different result. So if you wanted to tell someone who's been rejected for a credit card what they might change if they wanted to get approved, that could be useful. Those are probably my favorites.
Thanks, Kim. Sorry, I wanted to go on a tangent and just point out that Kim has 5 solo goals. I'm sorry, Kim, I didn't know that. I should have known, but I just learned this fact.
You just learned that fact?
Yes.
Yeah, I'm a competitions grandmaster.
For the audience, you need 1 solo goal as a requirement, which is like one of the hardest thing. And 5 solo goals is like somewhat unheard of. Not at H2O though, but generally it's unheard of. All right, I'll stop my Kaggle fan moment. Thanks for those answers. Can I ask what's your favorite interpretability approach in maybe driverless AI or any app in the AI cloud that now we've put out? Any app that already exists on there. Maybe I'll frame it like that.
Well, I had mentioned Model Analyzer, which can be used for understanding counterfactuals, how you might actually make changes in order to change an outcome. Certainly, Hydrogen Torch is really nice for analyzing image and NLP data and understanding what part of an image if the model's looking at, if you either have a correctly classified case or an incorrectly classified case.
Thanks, Kim. Sorry, I was just screen sharing to Hydrogen Torch and the other apps. And again, if you want to check these out, I also, as a reminder, have all of the links in the description of the video. Same question to Parul or Kim, if you want to answer that.
So I think open source we've already talked about, and driverless AI also has a lot of interpretability tools like Shapley values, K-line, loco, surrogate decision trees, and even it has disparate impact analysis also. So I think all of them, every method has its use. And at a specific point of time, you make use of, you use one in your analysis and you make use of another. So you sort of you might start with feature importance, and then you take the important features, and then you see their partial dependence plots, and from there you see the Shapley values. So that's what most of the times I use. And yes, that makes them my favorite also. And I use Tribal SAI. Otherwise, I also use a lot of open source products also.
Thanks, Parul. As a reminder to the audience, the later half is for your questions. So I'll keep it open for your questions. Just put them in the chat if you have any. In the meantime, I'll also again like this is another vague question, but maybe something that's on the roadmap or some recent paper that you were excited that might be added in the roadmap. If you could talk about that for any of our products.
I'll say one thing. So I mentioned before, or a couple of us have mentioned the explainability suite in open source. So we're working on a Wave app for that. So it's basically all the same stuff, but just in a different interface where it's completely, point and click. So, upload a data set, train an AutoML, and then do a full explainability suite on that. And so basically just repackaging a lot of the stuff that we just have already, but in a Wave app. So that's something I'm excited about.
Thanks, Erin. And also just want to share the fact that Erin is super active on Twitter. So if you're excited to try that app out when it comes, you can always keep up to date by just following her on Twitter. Unfortunately, she shares a lot of R stuff. I'm a Python person. maybe I'll try to convince her to do more Pythonic stuff. Sorry. Kim, Parul, same question to you.
I think with regards to open source, I think Erin is the best person to ask because she's the one who is associated with creating and launching products. So I think what she's answered, she might have answered for me also.
Yeah, what I'm currently working on is something Parul had mentioned earlier, a what if analysis for time series. So if you have a time series and you know that it depends on underlying features like maybe weather, how you might look at different scenarios. If we have a really hot summer, how might that affect something like energy usage, or something like a recession? If you're looking at maybe sales data, you could try to simulate that for time series data. So that's one thing I'm working on right now.
Thanks, Kim. All right, so the audience seems to be a bit quiet today. I don't see any questions. You can.
So if I just wanted to add because our panel is at a time. So yesterday, if people must have heard, the NIST or the National Institute of Standard and Technology, the US government, they released the AI Framework 1.0. So it's basically a risk. So if you want to share it on the screen, or I can share the link with you. So it's a risk management framework, and it was put out yesterday. It's a voluntary framework for the organizations who want to build trustworthy AI. But because this has been built in collaboration with industry and with academia and of course the government. So this is a pretty interesting thing if people want to read about it and what things, it's voluntary, what people want to keep in mind when creating a responsible AI product. So I just wanted to share that before I forget about it.
Thanks, Parul. So I still don't see any questions from the audience. You can leave a comment on the video if you're catching up later on. We'll try to get back to that comment on YouTube. For the panel, anything that you wanted to discuss that I might have missed? I've run out of my dumb questions.
I'll just say something to people that want to learn more deeply about these different methods. Like one resource to get a lot of papers and all the new research in this field is the FACT website. So FACT is FACCT, I think, is an acronym. it's one of the big conferences on like fairness. I think it stands for Fairness, Accountability. Yeah. Fairness, Accountability, and Transparency Conference. And they generally have all the papers on there. So, and that's kind of the big one that a lot of people submit papers to. So if there's any kind of really new, exciting methods, you'll probably see them there first. And then eventually those methods work their way into different open source tools and products. But that's the best place to look for new stuff.
Thanks, Erin.
And just to add on that, I think there's a book by H2 itself, I think, on O'Reilly, right, Sanyam, which is written by our interpretability team. So that's also a very good resource to. I had that. So it is called Responsible Machine Learning: Actionable Strategies for Mitigating Risks and Driving Adoption. So this is available for free on H2's website. I can share the link. So since I am be able to share it.
Yes, I was trying to find it as well.
So this is a pretty good resource also to study. You just have to like sign in, and this is free for download. Yeah.
Parul. Kim, did I miss anything that you wanted to cover?
I didn't have anything else.
Okay. So I'll try to wrap up in interest of the panel's time. Again, you're welcome to check out all of our open source work. Erin is the leader of that, and as you can see, we really put a lot of effort into those. If you're an enterprise, you can also check out our other products on the AI cloud, the apps we've been talking about. All of the links are there in the YouTube description. If you can't find anything, just leave a comment. I'll get back to you. You can find all of our panelists on Twitter. I've shared their links to the profile also in the description. They're also pretty active on LinkedIn. Parul and Kim are also on Kaggle, so you can also find their Kaggle profiles. Erin, I don't think is very active on Kaggle, but you can keep up with her work on our open source pages on GitHub and also the website. Did I miss any platform? All right. Once again, thank you to all of you for joining the panel, and also thanks to the audience. Thanks for doing this.
Thank you so much for having me.
Thanks for having us.
Thanks.